Perhaps in ESS ICCA.org, ess.icca.org, perhaps with
ICCSA.
ECC,
Yes.
ECC.icca.org.
Yes. ECC.ICCSA.org. Oh, it's not working.
I shared the link for the template if you want.
All right.
In the chat.
I can start? Can I start the presentation?
Some problem. Can you hear me? Yes.
Thank you very much. Thank you very much. I got it.
Good.
Can I start?
Yes. Welcome to this session, General Track. I will present you. I will introduce you. The first presentation is Kinesius, a system for telerehabilitation and functional analysis for therapies for physical rehabilitation after a stroke. The speaker is Luis Scudeletti. You can start. Thank you.
Okay.
I remember that each speaker has a maximum of 15 minutes, please.
Okay.
Thank you very much.
Hello, my name is Luis Rogério. I am a student at the São Paulo University State, and I'm grateful for everyone's presence. I prepared a presentation that I will start now. In this study, I present KinesiOS, a system of telerehabilitation and recognition of movements for motor and neurofunctional evaluation of patients in rehabilitation after a stroke. Stroke is one of the diseases that kills and incapacitates the most people in the world. It occurs with the rupture or blockage of a blood vessel. Thus, the oxygen and nutrients that should be carried to the brain are suppressed, causing damage to the brain tissue. Among the challenges faced by health professionals in the process of rehabilitation of patients is the difficulty in obtaining accurate data on the evolution of patients and the monotony of treatment decisions, which causes some patients in recovery to give up or not perform their activities with necessary attention. Aiming to assist health professionals in solving these situations, we developed the KinesiOS system, a motion capture system that calculates the amplitude of movements during rehabilitation sessions and allows telemonitoring. The capture of movements is performed through the Microsoft Kinect One device. The use of markers is not necessary to perform joint tracking, as Kinect projects a grid of infrared points through the space in front of it, and captures the reflections of these points when they collide with objects, calculating how long each emitted point takes to be reflected back to the device. detecting those joints and generating spatial coordinates at 30 frames per second. The coordinates obtained by the device are used to create the virtual skeletons. A virtual skeleton reader, which uses the coordinates recorded by the remote professional as actually a reference guide for the exercise to be performed by the patient. And a virtual skeleton displayed in red, which illustrates the patient's movements being performed in real time. In addition, the amplitude of the movements performed are calculated and displayed to the remote professional in real time. All data processed by the system is sent to a database in the cloud. If the specialist is not present at the rehabilitation site, he can connect to the system and view the data in real time and even send the patient new exercises so that he can perform them in non-clinical environments. Initial tests with health users were successfully conducted, showing that the application is effective, simple to use, flexible, because it automatically adjusts to anatomical structures of varying sizes, and low cost, which makes the project viable. In the image, we see the amplitude of movement of a user's shoulder flexion during the interaction with an application that allows the assembly of the pieces of a virtual puzzle, where it is possible to identify the moment when each piece of the puzzle is assembled. When the user performs the horizontal abduction movement with the right arm to pick one of the pieces, the amplitude of the movement was greater, and when the user performs the horizontal abduction movement to fit the piece in the matrix, the amplitude of the movement was smaller, near zero. The next steps of the project will include tests with more complex movements, in order to evaluate if the results presented will remain consistent and if it will be possible to measure the evolution of the patients. The system behavior will also be evaluated in several environments, with different illuminations, objects on stage, and movements with mean conclusion, in order to measure the limitations of the application.
Now, I am going to show a little bit of the system. This is the system login screen. Enter the username and password. This is the initial screen of the system, and here we have the option of the menu. To start capturing the movements, the first step is to register the patient by clicking on the patient options in menu. Enter our required fields and clicking Save, or select the client in grid, patients in grid, and edit or delete patients. Now, we have to register the patient's medical record, informing details about the patient health. The patient's medical record, save the medical record. Now, we access the motion capture screen. On the screen, we have the Kinect camera, and but can hide the video if necessary. Click in no video. We also have the member selector and command buttons. We must select exercise button. Click in select exercise. Select the example exercise. The patient must stand in front of the Kinect and try to perform the same movements as the guide exercise. I use an example now. The green skeleton is a reference movement. The red skeleton is real-time movement. The patients can simulate the movement reference. The movements in reference. No video example. The range of motion is displayed in real time, so that the professional can assess the patient performance. To record the movement, just click in the Start Record button and enter the exercise data. Select the medical record. Inform name, exercise, and save. The exercise is recorded. The objective is to record all the patient's rehabilitation session, watch the recorded session, and measure the patient evolution. For open movement, click, and the movement is playback. If necessary, can select specific members: left arm, right arm, upper limb, upper joints, and the others. It's possible pause the exercise and set the new frame the movement. This is a summary of the system. If anyone has any question, I am available.
Thank you very much. Thank you very much for your presentation. Any question? I think is a useful application, in particular in this pandemic period. No, it's very it's very useful. Useful for the patient. Good. I thank you for your presentation, and we'll start the next.
Hello, please.
Welcome.
Yes.
I'm not from this lecture, but could I ask a question?
Yes. Please.
Yeah. Right. I would like to know what kind of system parameter this presenter used to develop the implementation part. The implementation part, which kind of a system parameter have you used in this system?
Yes. Can you reply, Luis Scudelletti? In fact, this pattern, no, this is I don't know if there is a particular implementation.
the implementation of the system.
Yes, yes.
We use the Kinect V2 for get the coordinates, and the coordinates send to application and calc the angles, né, range of motion of the joints, and the joints are showed in skeleton. Okay.
Okay.
This question.
Yes, thank you. Thank you for your response. Any questions? If there isn't, we can move on the next presentation. The next presentation is breast fine needle cytological classification using deep hybrid architecture. The speaker is Hasne Zerouawi.
Thank you, Professor Sergio. I will share my screen. Can you see it?
Yes.
Yes.
Good.
Okay.
Thank you very much.
So I'm very pleased to be within you today. I'm Hasna Zerouawi. I'm a software engineer and a PhD student in Mohammed VI Polytechnic University in Morocco. I work in the MSDA lab under the supervision of Professor Ali Idri, and today I will present our work titled The Breast Fine Needle Cytological Classification Using Deep Hybrid Architectures. To do so, I will follow the following outline. I will first give a brief introduction, then the experiment configuration, data preparation, empirical design, the results, and finally the conclusion and perspectives. So first, as we know, breast cancer is the most commonly diagnosed cancer for women worldwide, and it remains a global challenge since it is the second cause of death for women globally. And as the number of patients affected by the breast cancer disease increases, it turns out to be hard for radiologists, pathologists, and oncologists to accurately deal with the diagnosis process in the constrained accessible time. So as a result, we have noticed that in the medical field, there is an emergence of computer vision, which uses in general artificial intelligence when dealing with the images. So more attentions are paid to imaging modalities, especially using machine learning and deep learning with the CNN models for the breast cancer classification. And this is what led us to our motivation for this study. So we wanted to evaluate the performance of 28 hybrid architecture that we designed using 4 classifiers, which are MLP, SVM, decision tree, and KNN, and also 7 of the most recent deep learning technique as feature extractors. So we use DenseNet 201, Inception V3, Inception ResNet V2, MobileNet V2, ResNet 15, VGG 16, and VGG 19 for a binary classification. So to do so, we put 3 research questions, which are: what is the overall performance of the hybrid architecture in breast cancer classification? Is there any deep learning technique for feature extraction which distinctly outperforms the other when used in the hybrid architecture constructed for each classifier? And final question, is there any hybrid architectures which distinctly outperform the other regardless the feature extractor technique and the classifier used? So the experiment configuration that we did to design the hybrid architecture. So we used 7 deep learning techniques as feature extractors by using transfer learning for feature extraction. So what we did is to freeze the last layer so that the deep learning technique can extract all the important features from the images. And we modify the top layers for all the 7 deep learning technique by replacing them by one of the classifier. I just want to note that for the classifier, we use the default configuration given by the scikit-learn library. So for the data preparation, we did use some the digital pathology or whole slide imaging, which is a subfield of pathology based on information generated from digitized specimen slide using computer-based technology. In our case, we use cytology or cytopathological images, and we follow the image processing, the following image processing scheme. So what we did first, we did the image acquisition, and then image pre-processing by using intensity normalization and Kldm to improve the quality of the images, and after that, image augmentations. So for the data acquisition, we used fine needle aspiration cytology or FNAC, which is a public dataset that contains digitized images reviewed by experienced certified cytopathologists, and that contains 212 images. For the data pre-processing, we improved the quality of the image and eliminated the noise and improved the contrast by using two techniques, which are intensity normalization and Kldm method. After that, we use the data augmentation for the training process after data pre-processing. And the goal is to avoid the risk of overfitting. So what we did is that we applied some strategies that include geometrical transformations such as shifts, zooms, flips, and rotation. And also we increased the number of the sample of the FNAC dataset. So from 212 images, we had 848 cytological images. By using data augmentation. The next step that I will present is the empirical design. So to evaluate the performance of the designed hybrid architectures, we use tenfold cross-validation, and we set 5 performance metrics, which are accuracy, sensitivity, specificity, precision, and F1 score. Also, we use Scott-Knott test, which is an exploratory clustering algorithm used in the ANOVA context to find distinction overlapping groups. So we applied the Scott-Knott on the hybrid architectures to cluster the best performing architectures based on accuracy. And finally, we used board account voting method, which is a voting method for single winner election. So in order to find the best performing hybrid architecture based on the 5 performance metrics. So this is the experimental process that we followed. First, the first step is to assess the performance in terms of accuracy of each variant of the classifiers. The second step is to apply SQ test method based on accuracy for each hybrid architecture. The third step is for each classifier apply SQ tests and board account based on the 5 performance metrics. The fourth step is to apply SQ tests on the best selected classifier of step 3, and the fifth step is to apply board account on the best classifier selected from step 4. So as a result, and in order to answer the first research question, that is, what is the overall accuracy performance of the hybrid architecture in breast cancer binary classification? So here in the figure, we have 4 diagrams that represent the accuracy values of 4 classifiers with the 7 deep learning techniques that are used as feature extractors. So I just want to say that for each deep learning technique, I make a legend. So each deep learning technique is represented by a color. So for the hybrid architectures using MLP classifier, we can see that the best accuracy value was obtained when using the DenseNet 201 feature extractor, since it reached 99% of accuracy, and the worst feature extractor is ResNet 15 with an accuracy of 70.92%. For the SVM classifier, the best accuracy was obtained using DenseNet with an accuracy of 98%, and the worst accuracy was obtained using ResNet 15 with an accuracy of 74.97%. For the decision tree classifier, we have the best accuracy was obtained when using DenseNet with an accuracy of 81.64%, and the worst accuracy was obtained when we designed the hybrid architectures combining decision tree and ResNet 15 with an accuracy of 71.80%. For the KNN classifier, the best accuracy was obtained when using MobileNet v2 with an accuracy of 87.37%, and the worst accuracy was obtained using inception ResNet with an accuracy of 69.54%. So for the second research question, is there any deep learning technique for feature extraction which distinctly outperform the other when used in hybrid architecture? So this question aims at evaluating the impact of the 7 deep learning feature extraction technique on the performance of the 4 classifier in order to identify the feature extraction technique that are positively impacting the classifiers. So to answer to this question, we applied SQ tests based on accuracy in order to cluster the technique that have the same predictive capabilities regardless the feature extractor used. So as you can see in the figure, we have 4 SQ diagrams, one for each classifier, and we can see different clusters for each classifier. So using the SQ test, the result shows that for the MLP classifier, we have 2 clusters, the best cluster containing 6 hybrid architectures, and one last cluster containing 1 hybrid architectures constructed using MLP and ResNet 15. For the SVM classifier, we see that the best SQ cluster contains 2 hybrid architecture, which are SVM with DenseNet 201 and SVM with MobileNet v2, and the last classifier contains SVM with ResNet 15. For the decision tree classifier, we find that the best cluster contains the hybrid architecture design with this decision tree and DenseNet, and that the last classifier contains 4 hybrid architecture using VGG16 and ResNet 15, Inception ResNet, and VGG19 as feature extractors. Finally, for the KNN, we can see that the best cluster contains 2 methods or 2 hybrid architecture, which are KNN with MobileNet v2 and with VGG16, and the last cluster is the hybrid architecture constructed using Inception ResNet and KNN. So the next step is to rank the elements of the best cluster for each classifier using board account and using the 5 performance measures metrics. So here we have the board account ranking for the hybrid architectures for the 4 classifiers, and in this table we represent the appearance of each feature extractor in the SQ cluster and their rank using board account. So as a result, we can see that the DenseNet 201 feature extractors appear 3 times in the SQ cluster and was ranked first 3 times using MLP, SVM, and decision tree. We can also see that MobileNet v2 appeared 3 times in the best SQ cluster and was ranked first, second, and fourth. The remaining the feature extractor appeared 1 time, at least 1 time in the SQ cluster. And finally, ResNet 15 feature extractor underperformed compared to the others, since it did never appear in the best SQ cluster. For the next and final research question, is there any hybrid architecture which distinctly outperformed the others, regardless the feature extractors and the classifier? What we did is that we took the best hybrid architecture for each classifier. For example, MLP with DenseNet, SVM with DenseNet, decision tree with DenseNet, and KNN with MobileNet, and we applied SQ test. So the best SQ cluster, as we can see in the diagram, contain 2 hybrid architectures, which are MLP with DenseNet and SVM with DenseNet. And also we have in the second rank the hybrid architectures KNN with MobileNet, and in the last cluster the decision tree with DenseNet. So what we did is that we applied board account for the best cluster, and using the board account voting method, we observed that the hybrid architecture MLP with DenseNet 201 was ranked first, and that the hybrid architecture using SVM with DenseNet 201 was ranked second. So as a result, we can conclude that MDen hybrid architecture outperforms the others. So as a conclusion, for the first question, we can conclude that the accuracy results of the constructed hybrid architecture were highly influenced by the deep learning technique used for feature extraction. In this sense, we can see that the DenseNet 201 for feature extraction in the design of the hybrid methods almost give the best results, and the ResNet 15 almost gives the bad and underperformed compared to the others. For the second question, is there any deep learning technique which distinctly, or is there any feature extraction that gives better results? So we can see that the hybrid architecture designed using DenseNet 2.1 for feature extraction gives the best results regardless the classifier, since it always belonged to the best SQ cluster and was ranked first. And finally, the best, is there any hybrid architecture that distinctly outperformed the others, regardless the feature extractor and regardless the classifier? We can say that MDen hybrid architecture, or what we refer to is that the hybrid architecture constructed using MLP classifier and DenseNet 2.1 feature extractor give the best results, since it belongs to the best cluster and was ranked first using the board account voting method. And also the accuracy value achieved by the MDen hybrid architecture are 99% using the FNAC dataset. As a future perspective, we want to compare the performance of hybrid architecture that we design with end-to-end architecture, which means only deep learning models to do the feature extraction and also the classification. And also we want to investigate homogeneous and heterogeneous ensemble, which members are deep learning techniques. Some references. And finally, I want to thank you for being present and following my presentation. Thank you.
Thank you very much for your presentation. Any questions? No? If there isn't questions, we will go move on. The next presentation is Kldm detection of interaction patterns through the execution of unplanned tasks. The speaker, I think, is Rui Duarte.
Yes, can you hear me?
Yes.
Yes,
Okay.
good.
I'll try to share.
Can you share? Yes, can you
I'll
share your screen?
Okay. Let me see if this works, because I have two screens. So
Good.
okay. Can you see the presentation?
Yes. Okay.
Yeah. Okay. So can I start?
Yeah. Yes.
Great.
Can you start? Yes.
Okay, thank you. First of all, let me welcome you all and thank you for being in the presentation of this work of Daniel. Daniel is a PhD student. He's not able to be here, so I will do the presentation for him. My name is Rui Duarte, and I'm the head of the Human Factors and Intelligent Systems Group from Research Center in Digital Services. We dedicate most of our time to work on human-computer interaction, and this is an approach that we tried to do for a while, so I think now we have something to show for you all. Okay. The agenda, the outline of this paper is as follows. First, we will look at the motivation for this work, followed by the definition of the problem and the contextualization in the state of the art. After this, a brief explanation of the Kldm model used as a basis of implementation for the unplanned interaction model. And before concluding remarks, we will show you all a demo application of the work that was carried out. Okay, so regarding motivation, the main motivation of this work is related to the increasing demand of users, which is related to applications that are available in the market. Many times what happens is that the cycle of update of applications, they are rapidly evolving and have also to adapt to the needs of users. Thereof, a usable application that provides an high level of performance is a very important fact to consider when the user chooses to use an application and becomes engaged with it. The time required for users to carry out tasks in an interface is an important factor in the interface design or redesign due to low performance. We have to consider both of them. After redesign, this sequence of task execution and redesign can enter a static cycle where redesign may not impact on the reduction of the time to execute a certain task. It's thus important to create tools to provide information for the designer on the interactions that took more time for the user to interact with an application. Several tools in this context, in this specific context, were developed in the scope of predictive models. And their relation to the performance in web applications has to be studied and considered. However, none of the applications deal with unplanned tasks. Unplanned tasks can be defined as tasks that a user carries out in an interface without a predefined path. Like we all interact in different ways with a certain application, we do not define a predefined path for us to follow. So this is the concept of unplanned tasks from users, and this is kind of difficult to configure. So one of the tools is Kldm Explorer, which has a complex system of pre-configuration of where the user has to click for the tasks to be completed and for results to be measured. In the Kldm FA, they improved on the Kldm software. However, the support and evaluation of the design was not considered. Moreover, SunLab offers, different from these ones, but they offer instability as a part of their central paradigm. This instability makes the path followed by the user to be very irregular and not measurable at all as a goal-defining path. Finally, Rachel and Bellamy verified that through the Kldm model, a scenario was slower than another scenario at the performance level. This is related to server answer, and it's a problem that has to be taken into account into software when we study interaction of users with systems. The main goal of this work thus is to identify performance issues of a web application defined as a score, which is depicted from interactions of a user with the application. Depending on these interactions, the system can have issues of poor interaction. Thus, the greater the score, the greater the degree of satisfaction of the user. A brief view of the model that we use to implement and to extract times of task execution is the Kldm model. The Kldm model is a brief explanation of keystroke level model, which is based on times of operators. This is a predictive model of interaction. As shown, it provides a set of operators that can be used to measure interaction times. These operators have their predefined values and are used in a sequence of interaction. In this paper, we use this Kldm model to predict in real time the time spent in a sequence of interactions and thus extract the total time of interaction, but also have discrete metrics of time spent in each of the interactions that the user took to complete a certain task. The developed work focuses in the development of a model that requires only a description of the task to be carried out by the user and the URL of the web page. Next, a set of performance indicators for the designers are provided based on the Kldm string generated by the Kldm model. This statistical tool allows the designers to assist the analysis of the reduction of the execution times of tasks carried out by users. Regarding the model, the general model of interpretation of unplanned tasks from user interaction, a general view is presented here. The designer develops an application and tests are carried out with users. For these users, he has a task that's specified, and next, the develop tool captures all the interactions that the user took in the parsing model and provides statistics for designers related to the interaction in the analysis model. This is then materialized in a statistical format for the designer to understand which were the operators that were more used by the user, and if with these operators and the time that they took in interacting, if something can be reduced in the interface design. The parsing model, all the interactions from the user are stored first in an XML file. This XML file is processed using Java and the Selenium WebDriver API, which acts on the XML file to extract information. Next, the Kldm is applied and the Kldm string is generated. This string contains all the interactions that the user executed in the interface, and it is mapped basically in a sequence of operators for the Kldm model. An example of a parsing model relates to the interaction with the text box. This is the generator HTML5. Basically, the user clicked to activate the text box and entered 15 characters, which is mapped into 15K operators. After processing of these XML tags, a Kldm string is created and contains all the unplanned interaction from the user. Once the user interaction is unplanned, the user can reach a goal following different paths. So we thought that we cannot give the user a predefined path where he needs to click. We need to capture what he does, not give him a sequence of interactions. So in this analysis model, the Kldm string is analyzed and the information is extracted from the user interaction based on keyboard, mouse, or a combination of both. And then performance indicators are provided to the designer to improve the design of the web application. To measure the accuracy of the implemented Kldm model, 3 assumptions were made in the framework. First of all, the system response time is neglected. That is, one of the operators, which is W, is considered equal to 0. Another assumption that we took and we gave the users was their hands needs to start in the keyboard and then only move the mental operator to the mouse once the interaction starts. Fit's law calculation is enabled, which indicates that the time of an action varies according to the distance to the target and the size of the target. When we look at the participant's task time, which is measured in real time, and the predicted framework time, we have a mean error of 8.43, which is the predicted error rate between keyboard and mouse-based, and which is within the 20% margin of error reported by Ivory and Hirsch. So after the model accuracy is set up, we started to identify patterns of interaction. Basically, what we want to measure is it possible by sampling with a lot of users, if in a certain time of an interaction, we can identify if an operator is within a specified margin, and then if so, a pattern is specified and the type of interaction is established. For example, if the percentage of operators, mental operators, in the keyboard interaction is between 18.44 and 13.76, then we can say that it has a keyboard interaction, but not only for the mental, but all the other operators. If they are all within this margin, then we say that the user did carried out a keyboard-based interaction, a mouse-based interaction, or a combination of both. For sampling, we present some tests that we did in several sources, either for keyboard interaction, mouse interaction, or a combination of both. And the different colors represent the intervals, and the interactions of the users are sampled in the interval. So from this, we can infer that we automatically detect the interaction that the user took in a specific interface without predefining or predetermining if he had to do it either only using the keyboard, only using the mouse, or a combination of both. Next, we show a demo application. In this demo application, we will have 2 examples of registration of a user account into websites, and next, just navigation. In this context of navigation, we just want to explore the mouse-based interaction, only mouse-based interaction. So let's start the video. Okay, so we consider 3 scenarios. First, in Spotify, we have a mouse keyboard interaction where the user fills freely the data that he needs to fill the form until the end. Here, all the data is being generated into an XML file, and all this information is stored that the user is executing in the interface. I will just push this a bit further because just filling form. Okay, is near the end. So all these interactions are then stored in an XML file that contains all the information and the tags that are related either by mail filling and the information of the mail and the number of interactions he had using keyboard in this context, and all the other interactions that he had in the interface. And these are to be extracted to create and generate a Kldm string. Then with the Kldm string is processed and statistics are generated for the interaction of the user. This example shows either in the pop-up or in the last chart that we have many key press interactions in the interaction of the user with the interface, which means that since we have many key press, a lot of changes between keyboard and mental and mouse are being used, which increases a lot the mental operator. That's the first in the first chart with 65% of time spent there. This implies that naturally the designer should consider to reduce the number of changes between interactions that the user has with the system, because it has a lot of time spent between mental operators and mental changes in the interaction. Next, using the information about the mental operator and the other operators, it automatically detects which type of interaction the user carried out in the interface. The next example is related to only interacting with the keyboard. Expert users use tab keys and so on. So this user tried and only used keyboard for the interaction. So now we press probably tab key to change between fields, not the mouse. Of course, beforehand, we don't know if the interaction will be like this. We just, in the end, we know that based on the interaction that the user had, we automatically detect which one was the interaction. Okay, and then another set of statistics are generated to the user, to the designer. Again, in the XML file where all the information is stored, and then after the processing stage, we have the statistics generated for the designer, which is most focused on interactions with keyboard. Therefore, K operators, as in the video. Okay. The final example is related with a user looking at or reading news. Okay. Navigation in Fox News. The user basically, what he does is that he just navigates with the mouse with no interaction with the keyboard. Of course, that the reading time is not considered because it is not measured by the Kldm model, which is a drawback of the use of this model. Just navigating, and then the generated XML file, and then some statistics related to navigation. And the automatic detection, which will infer that the user did and carried out and executed a mouse-based interaction. For more specifics and science and math behind this, we should refer to the paper, not to overwhelm you with the formulas. Okay. So, as a conclusion, in this tool, what we have here is a tool that you use the Kldm model to extract the performance, and the user interacts freely. We do not control, we do not say what he has to do on the interface. We just ask him to carry out some tasks and reach a goal. The way he does and how he reaches the goal is user dependent. All the interactions that the user carries out are mapped into a Kldm model, and we extract from this model and the string that we generate performance indicators to assist the designer in the improvement of user interfaces. Moreover, we also detect automatically the type of interaction that the user executed on the interface. On future work, some of it is already being developed, we look at it as a basis of this work as a basis of work for a more complete and more complex system. First of all, we need to create a recommendation system for designers based on several problems that are detected on interactions. We want to provide designers of solutions of how to improve the quality of the interface. Moreover, we would like to associate it with emotions that can be captured in real time to determine, in fact, if when the user is interacting, either pressing a button, pressing a key, or changing mental operator, if the KLEM operators have emotions. This is a question that's a nice question to ask. Does those letters have emotion in interaction? And if you can define patterns of interaction. And once again, one of the aspects that was neglected in this case was the W operator. That is, the system does not take time to respond, and sometimes this happens, which increases the performance of systems. So, is it important? One of the questions in this last scenario of future work is it important for us to take should we leave some stuff in the server and then bring it to the user, or should we give it to the user to reduce the waiting time of task completion, and thus making the interface more agreeable and more interesting for the user? Thank you all for your attention. If you have questions, feel free.
Thank you. Thank you, Rui Duarte, for your interesting presentation. Any questions? No questions? If there are no questions, we move on the next last presentation. Modeling of moisture effect in soft evaluation of soil interacting masonry wall structures. Who is the speaker of this presentation? Is the last speaker not here? Emma Vagaggini, Martina Ferrini, Mauro Sassu, and Mauro Lucio Puppio. Nobody? I don't know. Some problem, Natale Amato? I don't know if I keep this event. Some question from Asne Zerwawi. The participation certificate, I think it's possible to download it from the website, no, or not? It's possible to download the certificate. Yes, I think, but can sign it by Osvaldo Gervasi. Please send me an email to Sergio Passo at unipg.it. This is my email address, and you can You can ask, you can send me an email, and after I will ask to Osvaldo Gervasi this certificate for ASNE.
Thank you.
Good. I don't know if the last presenter is not here. I think the general track is finished.
Yes, bro.
We can close the session.
Yes, remember to complete the evaluation form, please.
Yes, of course. Thank you very much. Thank you for all to Natalia Amato. Thank you. Bye. See you.
Bye bye.
Thank you.
Thank you.
Everybody.
Streaming is on.
is on.
Hello.
Oh, I'm the chair of this session, Елена Станкова. Hello.
Hello.
Hello, I'm the chair of this session,
Yeah.
Елена Станкова. So I think we can start. Alexey Stankus, are you here?
Yeah, it's me.
Wonderful. So let's start. Oh, no, 1 minute more.
Okay.
So we wait. Okay. Maybe somebody will join us.
We'll see.
Alexey, you can share your presentation.
Sure.
Okay, let's start. So let's start our session, Scientific Computing Infrastructure. We have started this workshop in 2015, so it's our 7th event, and I hope it will be as successful as the previous workshops were. So our first paper, Textual Analysis of News for Stock Market Prediction. The authors, Bogdanov, Bogan, and Stankus from St. Petersburg State University. The presenter is Alexey Stankus. Please, Alexey, the floor is yours.
Hello, everyone, and good evening. Today we will speak about textual analysis of news of stock market prediction, but and the main topic of this will be compare different classifier and neural network to predict market news, first of all, and the main goal is to prepare how to prepare news for stock market prediction, because a lot of papers, a lot of articles, they're speaking about more that they have some news and they have some data, market data, and just try to make some ideas of how to predict market, but almost none of the articles how to prepare news and compare some different classifiers for prediction. Okay, what we have next? Sorry. Yeah, I spoke about this. So what we had when we started doing our research, we did several. We calculate a lot of news from different resources. So we have from Bloomberg, BBC, CNN, and so on, and as a news from text news. And we have market news, and we decided to take just S&P 500 as a main market going up and down. So, and we'll compare how the classifier works. You can see the list of classifier, and we will use one neural network, LSTM, which like a main goal of all researchers who try to predict market. Okay, so how we'll do it, and just here to just step by step. As if we will speak about classifier, we'll take it news text, convert text to vectors, and we'll speak about this later. After that, we'll get an average vector, and I will speak about how to get the best of average. And after that, we'll put this data to classifier and to see what, we'll put the classifier plus we put this S&P 500 data and see how classifier work. If we're speaking about neural network, there is a little bit different steps. First, we'll have news text. Then we have to extract a specific number of keywords from this text that after that we can move it to vectors, and only after that put is inputted in a neural network prediction. So let's speak about vector representation first of words. There is two big classes. First of all, the back of the world model, and second of all, world embedding. The world embedding is more likely you have an n-dimension vector, and the vector, and the main goal is to put words with pretty close, with pretty similar meaning, pretty much together. So how they do it? The main idea is to give this cosinus similarity. It's much better way that back of the world model, because back of the world model it's more about how many entries the word in the news or in the vocabulary, but they are not speaking about the similarity about the word. So pretty much same the word can be pretty far from each other. Okay, and there is, most of you know, there is two main libraries to do this, to translate word to vectors. First of all, the word to vec, and second is the glove. So we'll test both of them to see how close they are to each other. Okay, and if we'll speak about preparing the text, first slide. If, for example, we for classifier we need single vector, there is two opportunities to do this. First opportunity is just to get simple average of this, of all words in the news. So, for example, if you will have news like Shanghai stock opening lower and they blah 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 blah, you can see that there is several words, and we put vector to this word. So here is the example on the bottom side of the slide. Another way is to do so-called term frequency invert dimensions of frequency. So it's much more about the TF is a ratio of the number of occurrences of a certain word to the total number of words in one text document. But if there are too many repeating of the word, this word will be how to say over presented in the news. So somehow you have to make better representation of different words, because some of them not very often used, but they're pretty important by their meaning of this word. So for this idea, the people use IDF, the invert frequency of occurrence of a word in all documents. So it's more about logarithm. So and the total TF minus IDF is looking like this, and you can see that if we'll do the same example that we looked before, the average will be a little bit different. So that's about how we'll present and what we are doing for preparing the text. The another idea is how to get words out. Is about neural network. We have to get some keywords, and these keywords can be pretty much different. I mean, you have to find out first of all the number of keywords, and we'll show you how to do it later. But most of all is a little bit about neural network too. It has several layers, and somehow it has a drop layer that can drop some words. So you can see the examples when Shanghai open lower and it's transferred to well, at least lower definition of the word, low number of the word. And you know, for example, that not all news has a different number of the words, so you have to figure out the smaller amount that give a good results. But we'll speak about a little bit later about this. So what we did some experiments on about. We calculate about 200,000 news, and we use for training about 180,000. For developing, we use 22,000, and the same amount for testing. If you can see, and we use two word-to-vector idea. First of all, word-to-vec, and you can see this first slide is about word-to-vec, and second will be about glove. And there's two big ideas. Can you see my mouse? Just that I'm moving a little bit on the. No, you don't really. Okay, I got it. We have two classes. One is the own trained word vector, so we train word-to-vec by ourselves, and another one is using the already pre-trained vocabulary. And you can see that we have pre-processing method, average and TF minus IDF for classifier and keyword for STEM, for the neural network. So you can see the result. The best results giving on the trained word vectors, and the best in you can see that TF minus IDF is better than average, but still the neural network give a better results than all classifier, and for so and the total the best of the best is still the neural network in the word-to-vec. How much money? Okay, I have 5 minutes more. If you see the oh, sorry, I didn't change it. This is not word-to-vec. I just make a mistake. This is a glove method to put the word to vectors, and you can see that it's absolutely same repeating. So the best results gives by neural network with not own trained, sorry, but with pre-trained model. So if we did a little bit more, we try to find out the optimal number of keywords, and you can see that from our experiments, our results, the best about a number of keywords for neural network is about 180. Also in dimension, and other gives experiments the same as we have a number of vectors, and we have accuracy. So the last time gives the biggest, but you can see that still all classifiers pretty much goes in a plate after 130, 1300 or 1500 vectors for word-to-vec, and the same for glove. So it makes sense that the dimension of the vectors is the same, is about 1300s to 1900s to give the best results. So if to see if we speak about this all about our work, we can see that the glove give a little bit better results than the word-to-vec, but not much really. And we did this all work like for past year, and for now there is pretty much there are several different algorithms that came out on the market, like transformers, and we might try to retest our results and see what we'll have on it. Okay, that's I think that's it. Thank you for your attention. Do you have any questions?
Thank you, Alexei. So, what about questions? Who have some questions? We have only one extra participant of our workshop, and so I will ask you a question.
Okay.
I think you have described this problem, but maybe once more for me, I don't understand quite clearly. Semantic connection of the world. Semantic, you have somehow digitized it, and it's very interesting how you can convert semantic, the content, to the, I think,
Okay, I got it.
realize this problem.
It's me. It's not. We didn't do any research about it because Word2Vec and GLAF is a well-known libraries. But we are speaking about that this. The pretty much. Well, for example, you have word cat and dog, and most of all, it won't be together. So it's pretty rare that somebody writing dog hate cats or cats run away from dogs. Usually cats and dogs are opposite, I would say, direction. So it doesn't really matter. So if you speak about word embedding, their vectors will be close to perpendicular. And if you speak about, for news, so we speak about news. There are several how to say. So it's pretty much, for example, war make oil price higher. There are several meanings. It means the war and the price are pretty much not similar, but they're the main words. So when you're doing some neural network researchers, they're pretty much to find. They're not very important to find these main goals. So when you're doing a lot of calculation about news, you try to find out all this, how to say, this word combinations. They are pretty close. But if you will see on the pre-trained models, you can see that they give a pretty good results. So how to explain? Sorry, it's too much words, but not making sense. It looks like that the pre-trained. So I was sorry for a second. Okay, skip this. We'll say this dog and cats, and when we try to do our own pre-training and to compare it to already pre-trained model, so it makes sense that if you take all the news in the world and give this training, it still give a better results than you're doing on some specific slice of the news. Sorry, but that's it. If I answer your question, but I don't.
Thank you. More or less, and I understand. And I think the percentage that you present in this, for example, table, I think it's not. It's about the accuracy. Yes.
It's accuracy about it's accuracy about market prediction.
Okay, but I think it's not very high. It's about 50%. So what I think achievement you will do to make it more, make it larger,
like
to increase accuracy?
Sorry to say it, but most of this article which we read and which we can see, if that truly gives the result, not putting it high by itself. All accuracy is about 55 to 65% so far, because there are too many things. I mean, it's about two things why the accuracy is pretty low and how in the way to put it higher. First of all, you have to do much more deeper analysis of the news, because, for example, news, there are several new type of news in the market. You can see on the news. One news is just the news that's about the immediate something happened, like 1 hour ago the airplane crashed or something good happens. But there are a lot of news is about that we have a bad economy because, and it's more like logical story. But it's not about news now. It's more about like the idea why it's going bad. So you have to first of all you have to split the news from one of them. Split the news and take the news that's on time. It's actual news. Another idea is if you've taken like S&P 500, it's just global indexes. But some news, and we speak about this, some news are pretty good. For example, it's same the idea about war and oil. If war somewhere starts, the oil price sometimes getting higher, usually getting higher. But in the same way, if the war starts, some other economies getting lower. So you have to specify news, and they predict market not by S&P 500, but more about the current level of economy, I would say. If you're speaking about gold mining or coal mining, you have to learn the neural network on this. If you're speaking about oil or agriculture or other thing, you have to teach the network to this perceptual. So S&P 500 is more about like an indicator, and 57% is okay for it. But you have to.
Okay, thank you. Thank you, Alexey. Very good presentation. We are nearly in time, and it's 6 minutes late. So the next paper is investigation on CV3 for parallel execution of queries to database. And the authors are Yulia Shichkina and Vladislav Shevsky. Are there any authors here? Nobody. Nobody. Okay, maybe later. So let's then start with the third presentation. Harnessing cloud computing to power up HPC application, the BRICS Cloud HPC project. The authors Jonathan Marquez, Jean-Ke Wu, Hing-Se Wang, Vladimir Korhov, Weverton Cardiero, and Philippe Navo. Are there any authors here? Okay, let's wait a little bit. I just connect with Russian author Vladimir Korhov, my colleague. Maybe he will clear up situation. Just a minute. Okay, we are very sorry, but we have some problems with the presenters. I don't know where the presenters of the second and third papers, but the last paper on the possibility of using neural networks of the thunderstorm forecasting, presenter is here, but she will join us, I think, in 5 minutes. So let's make a little break, and afterwards we'll have chance to hear at least one more presentation. Okay, at last, the presenter. Presenter is Irina Tokareva, and the title of the presentation on the possibility of using neural networks for the thunderstorm forecasting. The authors are Irina Tokareva, Natalia Dichenko, and Elena Stankova. Ira, the floor is yours.
Okay, thank you. Can I turn off the camera? It's
Yes, of course.
okay. So, can you see?
Yes, we
Yes,
see.
yes.
So hello everyone. Again, my name is Irina Tokareva, and I'm presenting our work on the possibility of using neural networks for the thunderstorm forecasting. Nowadays, the forecasting of dangerous convective phenomena is a very important task because of the destruction they produce. So mathematicians and programmers for many years have been trying to improve existing numerical models that are used to simulate clouds and used in forecasting. Nowadays, machine learning methods, especially neural networks, are very promising in improving of such models, mainly because of the absence of model bias and possible savings of computational resources. Because after subsequent training, neural networks do not need many resources to perform the calculations on the test data. Neural networks actually have already shown their effectiveness in tasks related to dangerous convective phenomena. For example, the very popular task for them is prediction of rainfall amounts. Also, they have been used to predict such extreme events as tornadoes and typhoons. In this work, we continue to explore the possibility of combining the numerical simulation and neural networks to identify the dependence of thunderstorm development on different convective cloud parameters. This kind of identification is very important for forecasting thunderstorm and other dangerous convective phenomena with the help of the numerical models that do not have log describing electrical processes. The data for our research was obtained during the algorithm shown on the slide. After we implemented the algorithm, we got the data that contains the samples with that correspond to presence of thunderstorm and the ones that correspond to absence of any phenomena. Neural networks, like all machine learning methods, significantly depend on data. So before we proceeded to explore the networks themselves, we needed to prepare the data. First, the data was normalized, and then we selected the most significant features using the recursive feature algorithm. On the right, you can see the graph of dependence of a number of features selected. And the graph of the dependence of the classification accuracy on the number of features selected. So in this graph, you can see that the highest accuracy was achieved when using 8 features, and the accuracy is somewhat about 87%. Here you can see the importance of individual features for this task. So in the previous work, we considered multi-layered perceptron and 2 types of perceptron complexes. Multi-layer perceptron was chosen because it's very popular amongst such tasks, and the structure shown here was obtained experimentally and shows accuracy of 89.1%. The perceptron complexes were considered as an attempt to improve this result. As you can see from the slide, it worked, and the structure that you can see here was obtained when we divided a set of input parameters into 2 different groups using a correlation map. For the second perceptron, we tried to fed 2 parameters that are density and pressure directly to the resulting perceptron, and accuracy improved even more. So in this work, we tried to explore the possibility of using radial basis function network for this task, because this is, first of all, very good neural network for solving problems of binary classification, and also it has a very simple structure with only one hidden layer. In the process, before we could train this network, we needed to set initial values for the radial basis functions that are used as activation functions for the neurons of the hidden layer, like this. neurons. These parameters are initial values of basis vectors and beta parameter. So first we tried k-means method that corresponds to the black line on this graph. Then we tried to select them randomly, which is 3 other lines, and the beta coefficient in the first. Okay. When we used the k-means method, the beta calculated for each neuron individually, and when we used random approach, we selected the beta ourselves. So we took like 1, 2, and 3 values, and these graphs are for accuracy, as you can see. Oh, I'm sorry, for Russian. I'm sorry. For the accuracy and for the classification error. Here we tried to determine the best way to set these values and to select the number of neurons in the hidden layer. So from this graph, we can see that the best results are achieved when using k-mean method and when we have 18 neurons in the hidden layer. The structure is shown here, and the accuracy is very good, 91.6%. And also you can note then classification error is also great. Then we considered the probabilistic neural network. This network is very similar to the radial basis neural network, only it has the number of neurons in the hidden layer is equal to the number of samples in the training set. So it basically stores the whole set. The accuracy that we got is 90.4%, and the classification error is considerably higher than the one that we got in radial basis network. In this work, we continued our research on the possibility of using neural network to build forecasts of dangerous connected phenomena. By the example of Thunderstorm, we have considered a total of 5 networks. As you can see from the table, the best accuracy was achieved using second perceptron complex and radial basis function network. But radial basis function network gave the smallest root mean square classification error. And its advantages over second perceptron complex are also the simple structure and the shorter training time. In future, we will further explore the possibility of using neural networks for forecasting Thunderstorm and maybe other dangerous connected phenomena. And specifically, our research should be focused on obtaining sufficient amounts of data for the training of networks. Thank you for your attention. If you have any questions, I'm happy to answer.
Thank you, Ira. So, who can have some questions? Alexei, maybe you? Are you here, Alexei? I am one of the authors, so it's strange for me to ask questions to my co-author. So please, if no question, Ira, thank you very much. You have saved us our workshop. Thank you. You have come just from your work, so I appreciate it greatly. Yes, your help. Thank you for very good presentation.
Thank you.
And don't miss to send me the last version.
Okay.
Okay, thank you, and good luck, Ira, for you. Okay, so let's wait a little bit. I think we will wait because we have some time I think about 15 minutes, yes, Natalia?
Yeah,
Yes.
but
Yeah, I propose to have a technical break because one of the authors has promised to join in a short while.
Okay, let's make
I
a
will
break.
check, so let's make a small break.
We have time officially. For 5 minutes, for example. Okay. I think somebody joined our conference. Vladislav. Yes. Vladislav, please start your presentation. Vyslavshevsky, yes? Okay, we are waiting. Investigation of CV3 for parallel execution of queries to database. We don't hear you. Switch the microphone. Vladislav, do you hear me? I don't hear you. We don't see presentation and we don't hear you.
I don't hear you.
Vladislav, maybe chat. Send.
Technical problems, he reports.
Okay, we will wait.
We could hear the noise.
Vladislav.
Vladislav, I think we heard your noise, so can you say something?
Can you hear me now?
Yes, but we have a terrible echo.
And now?
Okay.
Now is good.
Oh,
Okay,
okay,
good.
thank you.
But we don't see your screen yet.
Yes. Where?
I think the screen sharing button is to the right from the camera. So you see microphone, camera, and then the third one on the left.
Yes. I'm setting it now. I need another 5 minutes.
Maybe you can try another browser like Google Chrome.
I'm here. Can you see something?
Okay.
Yes.
Okay.
Yes, we can.
It's good.
Good. Okay. Can I start?
Yes, please.
Okay. Have a good day, colleagues. My theme is investigation of CV3 for parallel execution of queries to database. Let's begin. We've made a part of query optimization by the first of all two types of query optimization. The first is dividing query by separate parts by amount of data. In the first example B, we can view that table is divided by two parts, for example. And the second types of query optimization is splitting query into subqueries, each of which compares a graph. The first and the main reason to optimize queries is problems with B3 algorithm. The main problem with B3 algorithm is that the parallel traversing through B3 can be doing well because the way we can doing traversal is the only way. We can't doing separate ways. We can't switch from, for example, A and B, from B to C, from C to D, to search the D node. We can only go the way A from B, B to D. There is the main reason to because there is some problem with this tree. We started to develop a new data algorithm that can store data in the subtrees that is in this presentation. The CV tree can contain several subtrees, which called CV subtree, and each of them is B-tree-like algorithm, but with additional relations with each of nodes, which I will show you in the next slides. The main algorithm of the adding new element in the subtrees is on this slide. We can add element some element of data in the CV tree algorithm, and by this algorithm we can select which of the subtrees will store this element in the in its own data structure. This algorithm describes the orientation of subtrees in the path of selection subtree, which will store the adding element. This algorithm describes the logic of adding additional start vertex. In the other words, we initialize not only root node from which we can start our searching. We add additional start vertices from which we can start search, and by this way we can parallelize our searching with some threads asynchronously. In this slide this slide is the example of my previous slide. For example, we have tree, the root node of which is with index 16, and this tree have 13 elements. We initialize additional vertices with indexes 6, 18, and 29. If we have 4 threads to search some element from this tree, we asynchronously start searching from vertex 16, vertex 6, 18, and 29. In this way, we can search element, for example, with index 31 by one disk operation. But if we search, if we will search some this element without additional starting vertex, we need to do disk operations. In other words, searching from 16 to 24 to 28 to 30 to 31. This is disk reading optimization, and in overall query execution speed optimization. This is an example of the searching within that tree. If we're searching element 1, for example, we decrease the number of disk operation needed to search node with index 1 in the previous slide. In this, go next. With testing, we've tested the proposed CV3 algorithm with the queries that are in the current slide. With tested select queries with different types of selection and searching strategy with join, with union constructs, and etc. The result of testing is on the current slide. You can see that blue is the query execution time on CV3, and red color represents MySQL execution query time. There was created two identical database in CV3 and MySQL, and executed the same queries in the previous slide. We can see that query execution time on CV3 is significantly less than on the MySQL database. Go to the next slide. There is a continuous from previous slide. CV3 show good result and have less query execution time than MySQL. The main results of this research is developed CV3 algorithm that allow users to search data faster than searching data from relational database management system, for example, MySQL. While searching this research, there was some publications created that are in the current slide. That's all. Thank you for your attention. Do you have any questions? Maybe?
Thank you, Vladislav, for your presentation. I think it would be much better if your slides will be in English and not in Russian. I think it's an international conference, and so you should translate your slides into English.
I agree, yes.
Please take it into account and don't do it like this.
Yes, of course. Thank you.
Okay, what about questions?
I have a small question, if I can.
Yes, please.
Ask. So Vladislav, could you tell me, so your approach, is it specific to relational databases, MySQL database, or it can work with some other databases like Spark SQL that have the same interface but have some different internals?
This approach can be used with all relational database management systems that uses internal engines which based on the B or B+3, because CV3 is the B+3 modification, maybe can say. But it can't be used on the NoSQL or new SQL database management systems. My aim is to improve the relational database management system that's based on the B or B+3.
Thank you.
I have a question. What is the main idea of selecting the root vertices, like for subtrees? Like we saw the equation, but what is the general idea?
I think I can show you this slide. Let's imagine what we have this tree. Yes, this can be B plus tree without relations between neighborhood vertices, for example, 8 and 24, 4 and 12, 12 and 20, and etc. If we want to find, for example, vertex with index 1, what we can do? We can do through root vertex with 16 and go to node 8, go to 4, and then 2 and 1. We do 4 disk operations, and if we have to search with different threads, we can't do another way. The first thread and the second thread will do the same work. The first thread will go through 8, 4, 10, 2, and 1, and the second thread will do the same work, do the same way from 16 to 8, 4, and etc. But if we will have additional vertices, we can do separate works with from these additional root vertices. For example, we can start from 16 and start from 6. From 16, we will do work from 16 to 8, to 4, to 2, and 1. But from 6, we can search from 6 and go to 2 and to 1. We can search some ways that can be what can be faster than going from a root vertex. This is the main reason of this new data structure.
No, I get it, but how, for example, did we choose 6?
This is on this slide.
Okay.
I can say that each of vertex store additional information about herself, about itself, and about its neighborhoods. For example, its vertices, its address, and when we add new vertex to this data structure, we go through the whole tree, and we select which of vertex will be optimized to select this vertex as additional start vertex. This is for example, the part of the algorithm that select the this is the part of this algorithm. So we select the additional start vertices on each operation of adding new elements, and we override old starting vertices, additional starting vertices, if we need to do it. So
okay.
By this way.
Thank you.
Okay, so thank you, Vladislav, and please be careful with your slides in international conferences. Thank you. And so I think we have the presenter of our third paper, Just a minute. Okay. I think harnessing cloud computing to power up HPC applications, the BRICS Cloud HPC project. Who will present?
I'm going to present Luciano Gaspari here.
Oh, wonderful. Please.
Just let me share my screen.
Mm-hmm.
Can you see my slides?
Yes, wonderful.
Perfect. So thank you very much for the introduction. And I'm sorry, I have no outage here in my city right now, so I hope I'm able to complete the presentation successfully. So I am Luciano Gaspari. I am an associate professor at the Federal University of Rio Grande do Sul, South Brazil. And I'm going to present a joint work we developed with St. Petersburg State University and Beijing Normal University. So this work was carried out in the context of BRICS STI framework program called 2016. The main idea, the main motivation for this work is that actually we have a world of problems to solve. We do have massive HPC infrastructures available in BRICS countries. And at the same time, we have so many open problems to solve, like in health sciences, environmental sciences, and so on. While we have, these are, of course, universal problems. Here you see, for example, fires, COVID-19, droughts, who are occurring very frequently in South Brazil. We have this very important aspect of population aging and the prevalence, lots of Alzheimer's disease cases in different countries around the world. So, to summarize, we have lots of universal problems, but also numerous local problems to be solved within our communities. So, it's difficult to provide this license to every research, and it's very expensive to possess own resources. So the main research problem that we proposed to address in this joint project is what if an institution doesn't have access to enough HPC resources? At the end of the day, we all know that this kind of problems, they do require HPC resources, powerful machines, powerful storage and processing capacity. But not all institutions do have this kind of resources. So our vision in this project was exploring the usage of cloud computing infrastructures as a means to promote the execution of very critical applications who otherwise would be executed in HPC, but due to the lack of infrastructure, we are proposing to execute them in cloud infrastructures instead. So there are some challenges to be overcome when we consider executing HPC applications in the cloud, because the performance that we obtain in traditional clouds is not the same as the one that we can observe in HPC dedicated infrastructures. And we have several bottlenecks, including application modeling, virtualization, and networking aspects that in clouds are more exacerbated than in HPC. So our goal to make this vision a reality is to improve cloud computing to provide a flexible, secure, and efficient environment for running HPC applications. So our focus in this project was on computer science related contributions and application modeling. And as you can see on this slide, our contributions focus on three main aspects: on HPC applications, on modeling HPC applications to be executed on cloud infrastructures. This is number one. Number two, we worked on lightweight virtualization mechanisms so that hosting would not become a very expensive bottleneck. And in the very bottom of this picture, you also see the networking as a major component of our investigation. For HPC applications to be able to execute in the cloud, we need a very efficient network because these HPC applications tend to communicate a lot. So, in summary, when we talk about applications, we have worked on large-scale medical image processing and on weather forecasting. When it comes to hosting aspects, we have worked on HPC application performance and cost efficiency in clouds. We have also addressed HPC application deployment, benefiting from instance heterogeneity in clouds, and platform services for performing HPC computations in cloud environments. And finally, a last important goal of this joint project was on computer networking, as I mentioned before. And we have worked on dynamic path provisioning and on link aggregation performance on clouds. I will not have time to go into all these contributions, but I will try to summarize 2 or 3 of them depending on the time that we have. So the first one of our contributions is on the HPC application side. So one of the main aspects of this project is this use case of our attempt to understand the brain. So in this project, we worked on the segmentation of cerebrovascular vessels precisely in an attempt to devise mechanisms for the prevention and diagnosis of cerebrovascular disease. However, this application is very computing intensive, and therefore we developed a processing and modeling platform integrated to the cloud to be able to execute this application in a timely fashion. The scope of this work was the analysis of the neural function of the population of 5 villages in one of China's districts, Beijing's districts. Basically, what we proposed in this project was an effective segmentation approach based on Markov random field and particle swarm optimization algorithms. And after doing this modeling effort, we sort of did a major attempt to make this application very time efficient. And for that, we made a big modeling effort to speed up its execution on a compute unified device architecture-based cloud. This was the first contribution. The second contribution was on how to deploy my HPC applications to the cloud. Because we as scientists, we really struggle to when we have to go into these cloud infrastructures and we have to decide what is best for my application. As there are different instances, there are different capacities, there are different prices that we can pay, we have to pay depending on what we need, but it's very difficult to make this decision. So what we and in many cases, the costly instances are not the most efficient depending on the HPC application that we would like to execute. So what we did in the context of this work was we proposed a process placement mechanism. The idea of this work was, okay, we have an application profile. The application I have has some characteristics that I know. And on the other hand, I have the profile of the cloud infrastructure. So the idea here was to come up with a placement mechanism that, given these two inputs, provides the scientist with a suggestion of instance combinations that he or she should purchase in the cloud. And not only that, we also suggest, the mechanism also suggests where to place each process after the creation of this cloud infrastructure. So here you see on the right a picture showing a bit of what we would achieve, for example, using an homogeneous cloud. For example, here we have an homogeneous cloud where we have 0 D4 instances and 8 FA instances. Here we have different combinations of instances. And here again, we have another possibility of instantiation, instance creation in the cloud. So what our solution does is it provides the scientist with the best option. The best option means the one that is less costly and the one that might lead to the better performance for the HPC application. And in one of our experiments that we did, that you may find in this paper that I'm citing down here, we show that for this particular weather forecasting application, the best alternative would be to allocate or to purchase 1 D4 instance and 7 FA instances. And that would lead to the best combination to execute the application on the cloud. So not only that, still in the hosting aspect, we have also worked on a lightweight virtualization platform that we can use to execute applications on cloud infrastructures. So this work was led by Professor Vladimir Kurkov, and he worked on a platform that allows the user to distribute his HPC application on the cloud. And a very important objective of this work was on automation. So one thing that you can see here in red is the idea of this platform is to obligate users from manually creating and configuring a virtual cluster. So this is one of the objectives that we try to achieve with this work. Secondly, this platform provides users with a simple web interface for submitting tasks for execution. And thirdly, and very, very important, aligned with what I just mentioned in my previous slide, this platform optimizes task execution time by offering users a better cluster configuration based on the history of executed tasks and heuristics. So if I must say, this is an improvement to what I just mentioned. In the previous work, we were just suggesting a better configuration. And here we are again doing some optimization work based on a historic execution of previous tasks. And we have also many knobs that can be parameterized to improve the performance of the HPC applications running on either a fully cloud-based infrastructure or a hybrid infrastructure, combining both HPC and cloud. I'm not sure if I have time, but just one minor words about our work on networking part, which is the third contribution of this work, this joint project actually. And I just wanted to mention that many studies have been made to make virtual machines and allocation of processes onto cloud nodes very efficient. But little has been investigated to make the network more efficient. And so in many cases, cloud infrastructures still resort to very static allocation mechanisms of communication channels. So in this work, we devised a software-defined networking mechanism for just-in-time path selection and provisioning. So the idea of this third contribution was to monitor the network conditions and reprogram paths to avoid congested links and ultimately reduce end-to-end delays. We have published 2 years ago in ICCSA a paper showing very promising results on the benefits of using software-defined networking to adjust paths so that the HPC application can really find a more adequate space to be executed in cloud infrastructures. And just to provide you with a very brief example, if we are working on a very dense scenario, on a very sparse scenario, and in a cloud infrastructure where we have, for example, a lot of concomitant traffic, as you can see here on the bottom right, our solution can provide application speedups in the order of up to 44%, which is a very good result. So, to end my presentation, this was a very interesting experience. Actually, it's not done yet. We keep our collaboration active, and I have to say that carrying out a joint project with partners from which are very far from each other is sometimes very challenging because of time constraints, because of budget constraints, and so on. And we have to say that the COVID situation sort of obliged us to suspend all our mobility efforts, which was one of the main objectives of our work. Nevertheless, it was a very good opportunity because we kept working a bit different than we were going to do by our first original plans, but we managed to keep a consistent collaboration between Brazil, between Russia, and between China, which was a very good result. This project is coming to an end, and it has led to 5 patent requests or software requests and more than 20 papers published in good reputation venues. And we hope to keep this collaboration working. And not only that, we hope to have a proof of concept implementation of a next generation cloud infrastructure so that not only us, but more people can use, providing us with important feedback to continue this investigation thread. Thank you very much.
Thank you very much. It's very interesting, detailed presentation, and it was worth to wait for you for so long time. Thank you. Do you have any questions, please? Well, I have some small question. You're speaking about regional atmospheric model, which you want to use in your research. But I think that atmospheric models are very difficult for parallelization. So how you intend to, I think, to use such kind of models in cloud environment?
Yes, you are right. Weather forecasting applications are really more challenging to be modeled as a fully parallel application. So our first attempt to address this problem was to work with DAGs, directed acyclic graphs, so as to understand to what extent these applications can be parallelized. So what we do have is like a big tree where we see, we try to find opportunities for parallelization. So for this kind of application, when we try to execute it on the cloud, probably the best approach is not really on choosing many instances, I mean node instances, but instead selecting fewer instances with higher capacity. So depending on the application, we can trade off a big number of nodes with a lower number of nodes, but with much more capacity. And that's something that we did in the second part of our project when I was mentioning about that work on a recommendation system on how to do this kind of execution in the cloud. But again, I fully agree with you. It's not straightforward.
Thank you. You also can change slightly the initial conditions. So you could, it's not parallelization, but parallelization maybe for data with different initial conditions, maybe for some series of experiments.
Yes.
Okay. Any more questions? No questions. So Natalia, so thank you very much for your
presentation. Thank you very much, and I hope you could hear well.
Yes, wonderful.
Thank you.
Natalia, sorry for being so late.
No problem.
Thank you.
Elena, remember to compile the evaluation form, please.
Yes, and where can I get it?
I send the link.
You send to
Now,
my
now,
email? No, to my email.
No, in the private message in chat.
In chat, okay.
Yes.
Okay. Thank you. And how can I? Okay.
Okay.
Uh-huh. Okay. Thank you very much. Thank you. And I think the first session of our workshop is over. Thank you for your participation. Okay.
Okay.
Goodbye.
Goodbye.
See you tomorrow.
Thank you. Goodbye.
Goodbye.
Thanks for everyone.
See you.
Thank you.